Almost everything we know is solid, liquid, or gas, but in our visible universe, this accounts for less than 1% of all mass. So of course, it's only reasonable to question what's the other 99% that Mrs. Turner didn't mention. Well, before I fill you in, here's some related theory, which I made sure to write neatly in case the teacher doesn't hear me. Now, kinetic molecular theory tells us that particles are always in constant motion, which should never have been postulated unless three wise men got a notion. Their names were Gay-Lussac, Charles, and Boyle, who created a formula to which all particles are loyal. They said that kinetic energy equaled 3kT over 2, where K is the Boltzmann constant and T is the temperature as an absolute. Furthermore, it was found that when particles move faster, it gets hotter. That's an actual law of physics, not a field note from Harry Potter. Thermodynamics are another topic to keep in mind. It states that heat is never gained or lost without a culprit to find. There are 4 specific laws which tell us how to keep it cool. Zero said that temperature of a third body need the first two to be in rule, and equilibrium with each other, unlike the second part, which says that although the energy with which you finish is the same as when you start, heat becomes work and work becomes heat, just as a closed thermal system's entropy is almost bound to increase. But when temperature reaches zero, this entropy tends to cease. Whoa, heat. Now that that's out of the way, it's time to introduce the main attraction, a phenomenon which causes earthbound solar flare refraction. It's called plasma when ionic bonds shatter, which led Sir Crookes and Sir Thomson to title it as radiant matter. And the little plasma is a key ingredient in stars. It also makes up most of what lies between here and Mars. It also has some uses of which Sony and Toshiba are aware, as lamps of ionized gases can be found just about anywhere. That is, anywhere with a big TV that hasn't already upgraded to LED or LCD. But from a societal perspective, what are plasma's pros and cons? To answer this, let's look at an example and see what's really going on. When you look at a bolt of lightning, you'll see the plasma approximation, which shows that these highly charged particles may create an electrifying sensation, but the real definitive trait is how close they need to be, as given by the sphere's screening length and parameter given by a plasmonaut, Peter Debye. It is because of plasma-based diffusion that lightning looks so big, because that faraway light beam of Thor's is almost as thin as a twig. And although thousands of people are thunderstruck every single year, its potential as renewable energy is becoming quite clear. Nikola Tesla suggested in 1902, back when the Nobel Prize was awarded to Lawrence Hendrikad in Thun, that electricity could be transmitted without the necessity of wired antics. But only in recent years have we understood atmospheric electrodynamics. How to guide the current as it travels through the air is a pretty important part if you want the banks to care, because money can't be made from Aurora Borealis, nor can people pay if their whole bodies begin to callous. The main reason this works was discovered by Fernando Galois, who found the charge of raindrops perpetuating research of this tech. So not only would these towers bring wireless power to us all, but it would also lead the number of people struck by lightning each year to fall. So all in all, as far as lightning goes, plasma's on the ball. Although it won't solve the energy crisis or act as a sudden cause of death, it has entertained billions and wasted billions when unkept. Let's take a look back to the year 1964, when the guys who hypothesized the Maser laser won the Nobel Prize in Physics for their work on amplifiers and oscillators. So anyways, it was in this year the plasma TVs were created, but if you waited to turn them off, the picture only faded, because the radiance of the plasma was so strong that it tended to burn the screen. You thought Mythbuster was on, but it was really just red-green. So how does this TV work with the standard RGB? X-rays hit a phosphor-coated plasma capsule at a high frequency, which determines the color and the brightness that we see. On a different note, plasma almost ended World War II, when the Nazis developed a device they hoped would rise when it flew. It was called the Bell because of its beryllium shell. Neutrons were shot at a thorium oxide core, which created X-rays of plasma, spun drums, and much more. Turns out this particle accelerator also produced uranium isotopes, for which the OSS had dramatic hopes. It just so happens that the plasma device of which I'm talking could have helped to make the world like Hiroshima or Nagasaki. So in retrospect, when we look at plasma altogether, it would seem just as relevant as a bird is to its feather, that noticing the importance of plasma doesn't take a good detective, just as every aspect of the universe has a good and bad perspective. And just as silent to spell with the same letters as listen, I hope you heard that without plasma, 99% of the universe goes missing. Thank you, sir.
Whoa, Peter!
Back in Nick.